Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's average level difficulty puzzle, and it's called A Song of Twice and Higher, or Lower, by Viking Prime, and I'm assuming it's a reference to the George R.R. Martin fantasy fiction series called Song of Ice and Fire. Um, but anyways, let's see what it is. Okay, here are the rules. Normal Sudoku rules apply, which means place the digits 1 through 9 once each in every row, column, and box. White dots separate two cells containing consecutive values. So that's important to say values. So, for example, if this contained a value of 6, this would have to have a value of a 5 or a 7. But it's a value of a 5 or 7. Now, remember that. It's not the digit necessarily. Black dots separate two cells where one is double the other in value. Again, there's too many dots for this to not be value. So, if this was a value of 4, it would have to have be next to a value of 2 or 8. Again, this is very important. Shade some cells so that all shaded cells are orthogonally connected, and all unshaded cells are orthogonally connected. Each 2x2 area of the grid contains shaded and unshaded cells. So this is a yin-yang pattern. So in this pattern, there's one contiguous set of shaded cells, and we're going to make it this one, and one contiguous set of unshaded cells. And there's no 2x2 area, or actually, each 2x2 area must contain at least one of each, either shaded and unshaded. So they must have one shaded and one unshaded. And that's each 2x2 area. So this is the yin-yang pattern, and this is specifically because we have one contiguous cell, or one contiguous region of shaded and one contiguous region of unshaded. And that's actually very important. There are shortcuts that you can use once you know that rule set. The value of a shaded cell is one more than its digit. Okay, so this is where we get into the value of things. The value of an unshaded cell is one less than its digit. Oh, interesting. Okay, so therefore no cell is equal to the digit itself. Huh, that's interesting. Okay, so the value of a shaded cell is one more than its digit. So therefore, if it's a 1, if, say, this was shaded, let's make that shaded, and say it was, okay, a 6. Oh, whoops. Say this was a 6. That means its value would be 7. And then the value of an unshaded cell, so say this was unshaded, we're going to make blue shaded and green unshaded, even though it's going to throw me off a little bit because normally blue usually brings things down. But anyways, so say this was a 6 unshaded, then that would be a value of 5. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. What does this mean? Okay, so the one thing I can think of, so since now the values are from 0 to 10 possible. However, there are still limitations on what it can and cannot be. So, okay. There's a lot of black dots, which means there's a lot of 1 to 2 ratios. You could have a value of 5 to 10 now. 7 is still not a valid value because 7 is not double anything, and 7, it can double, it becomes a 14. 9 is also not a valid value for a black Crocky dot cell, right? Because 9 cannot be double anything, and 9 doubled is 18. But 5 can be actually correct. So then we have to rework what we know about black cells, right? What we know, okay. So anytime there are cells which are next to a black dot, what we know now is 1 can be up to 2, which is valid. 2 can be down to 1, which is valid. It cannot go to 3. Oh, 3 is valid too. So 2 could go to 1 or 3, which is valid. 3 could go to 2 to 4, which are both valid. 4 could go to 3, which is valid, and 5, which is valid. So 3 and 5 are valid. So 1, 2, 3, and 4 all can be valid. 5 can go to 4 or 6, which are both valid. 6 can go to 5 or 7, only of which 5 is valid. 7 is not valid. So 6 has to go down to 5. 7 goes to 6 or 8, which are both valid. 8 goes to 7 or 9, which is not valid for either. So 8 is the digit that can never be next to a black dot. 9 can go to 10 or 8, which are both valid. So we know that if there are 8 digits that are connected to 8 unique digits that are connected to a black circle, the 9th one has to be an 8. Because the 8 can only go down to a 7, which cannot double anything, and when it's doubled, it's 14, which is not a valid value. Or it goes up to 9, which it cannot double a value, and when it doubles, it's to 18, which is not a valid value. So we have 2 sets of boxes where that works. These are all connected to a black dot, so that's not. So therefore, this has to be an 8. And these 8 are not connected to connected to a black dot, so this has to be 8. So we know this can't be 8, this can't be 8. These are black dots, which cannot be 8. Therefore, the 8 has to be one of these 2. Because it can't be connected to the black dot. Well, that's also Sudoku. So the 8 has to be one of those 2. Which means the 8 has to be one of those 3, but it can't be connected to a black dot, so it's one of those 2. In addition, we know, okay, 6 has to go down to a 5. It cannot go up to a 7, because if it goes up to a 7, 7 again cannot be doubled, cannot be a double of anything, any value, and 7 doubled is 14, which is not a valid value. So 6 always has to go down to 5 in this set. So 6 has to go down to 5, and therefore 9 has to go up to 10 to make a valid set. And the question is there any scenario where there's a 5-10 pair? I guess it could be 5, 10, then 5, right? Right, so there's only one digit that can get to a value of 10. So you can only have 5, 10, and then 5. You can never have 10, 5, 10, or 5, 10, 5, 10. So these are all connected in values from 2 to 1. So if you tried to have 5, 10, 5, this would have to be a 10 also. But that's not possible because only one value in a set of the Sudoku can be up to 10. Therefore, this cannot be part of the 5, 10. Therefore, this is 5, 10, 5, which means this is the 10. So this is the 9, and we know it's shaded because the value of a shaded cell is 1 up. So this has to go with 5 and 5. So this is 4 and 6. which means one of these is shaded and one of these is unshaded. This 8, we don't know. Similarly here, if you go here, these are all connected too. So it cannot be 5, 10, 5, and then you have another 10. This has to be 5, 10, 5. So this is 4, 6, and this is 9. Therefore, this is 4, 6. Oops. This is also 4 and 6. So this also has to be high. And then, okay, so for one thing about, okay, one shortcut for yin-yang is once you've switched the polar or the coloring of the region, you cannot switch back within until, sorry, you can only switch once either way. So we know one of these is shaded. We also know one of these is unshaded. So if this is shaded, this has to go with the other shaded. And if this is unshaded, it has to go with the other unshaded. Because if this were shaded, and then it went to an unshaded, but then this is unshaded and it goes to a shaded, this never works, right? So like, let's look at the scenario where that's the case. The reason why this is the case is these unshaded cells have to be connected in some way orthogonally. I forgot to say orthogonally means it has to be connected by an edge. Anyways. But because they have to be connected, that blocks off this shaded cell region from this shaded region. So you have two shaded regions, which is not valid. Therefore, you know whatever color this is has to be the same color as this. Whatever color this is has to be the same color as this. Let's make it, I don't know, pink and orange. So this has to be orange. So we know all of these are orange. And we know this is pink. Because so then all of those have to be pink. We don't know what these are, but we know that this has to be the case. Okay, so then this becomes 1, 2, 3, 5, and 7. What it cannot be. I think it always has to be values of 1, 2, 4, and 8. Can you ever have 3, 6, 3, 6, 3? No, because 1 always has to go up to 2. 2 could be 3. So 1 and 2 have to be next to each other. So this is also the case here. This is 1, 2, 3, 5, 7. This, interestingly enough, has 4 values where it's doubled or less than. Right? I think the only one that fits that criteria is 4. A value of 4. If you didn't have a value of 4 here, say we tried 2. 2 would have to be next to... There can only be, at most, 2 cells which have the same value. So that means 2 of these cells would have to have the same value. And then the other 2 cells would have to have a different value of 1 to 2. If you had a value of 2 here, that would mean that you would have to have 2 cells which have a value of 1. But that's not possible. Only 2 can go down to 1. Therefore, this has to have a value of 4, which has to have 2 cells, which has to be next to 2 cells with a value of 2, and 2 cells with a value of 8. Therefore, we have 7, 9. So this can't be 9, and this can't be 9. So 9 has to be one of these two. So the 9 would be going down. The 7 would be going up. Okay. And then you have a value of 2, which means 1 goes up and 3 goes down. Right? So they have a 1, 3, 7, 9 quad set in box 3. So there cannot be a 1, 3, 7, or 9 anywhere else. Therefore, this is a value of 4, remember, which means it's either 3 going up or 5 going down, but the 3 is already eliminated, so this has to be a 5 going down, which means it's unshaded. And therefore, these have to be all shaded and going up, therefore. Therefore, this is a combination of 1 and 7, because 1 has to go up to 2, and 7 has to go up to 8. And this has to be a combination of 3, 9. And therefore, these are down. And because of the 2 to 1, or 2 by, every 2 by 2 square has to have a shaded and an unshaded. This has to be shaded. Because this 2 by 2 square has already 3 unshaded, and that has to be shaded then. So this can no longer be 5. The purple we now know is unshaded. So this is shaded, which means the value goes up. So this has to be a 4, this is a 6, this is a 4, this is a 6, right? The 6 has to go down in value to a 5. The 4 has to go up in value to a 5, and this is 10 value. So this can no longer be 5. We know, okay, so this is this can't be 4, this can't be 4, so therefore this has to be a 4. This is an 8. We now have a 2 to 6 ratio. This can't be 6, so this is a 2, and this is a 6. Okay. This goes up in value. So it cannot be 2. It could be 1. It could be 3. It cannot be 5. So it can't be 2 or 5. It could be 7. Remember, because it has to be 2, 4, and 8 in value. Or 1. 1, 2, 4, 8 are all valid values. It cannot be 3 because we tried 3, 6, 3, 6, 3. That doesn't work. Because 1 can only go up to 2. So 1 always goes up to 2. So therefore, it has to be multiples of 2 or division by 2. So it has to be 1 to 2 to 4 to 8 in that set. Therefore, the 7 has to go up in value. Okay. Okay, so this is 1, 3, 5, or 7. The 3 and the 5 are here. They both go up. One of them goes up. So 3 could go up to 4. 5 can go up to 6. But 4, so say this was both 3 and 5. Wait, hold up. No, they go down. Right, these go down. As I said, I can get mixed up with the ups and downs. Okay, yeah, again, so if, okay, 3 and 5, these are unshaded. The value of it is 1 less. So 3 goes down to 2. 5 goes down to 4. So this could actually maintain a 3 to 4 ratio. If this is 7, it doesn't work. If it's 1, it doesn't work either, right? 7 goes down to 6, which is not a 2 to 1 ratio with 2 or 4. And we know one of these has to be 3 or 5 at least. 1 goes down to 0, which doesn't work with 2 or 4. Therefore, this has to be a 3, 5 pair. So this is 1, 7. These both go down in value. So this is 3 and 5, which goes down to 2 and 4, which is a 1 to 2 ratio. So this is either a value of 2, 4, 1, 2, 4, or 8. 1 could be a 2. So 2 could go down to 1. 1, 2. So it could be 3 down to 2, but that's not possible because that doesn't work. So 1, 2, 4, 5 going down to 4, but we already have a 5, and a value of 8. So this could be 9. So it could be 2, which goes down to value 1, 3, which goes down to value 2, and then 5, which goes down to value 4. So it's 1, 2, 4. So that works. Or it could be 9, which goes down to value 8, 5 goes down to value 4, and 3 goes down to value 2, so that would be 8, 4, and 2. So either one works there. Okay. Let's see. This is 8. We don't know which way that goes. This has to be 1, 3, 5, and 7 also, but they're going up. We can't eliminate anything here. This would be 2, 4, 6, and 8 in value, and we don't know what that is. So it could be 1, 2, 3, 4. It could be... There's a lot of things. Okay, these go down in value. These go down in value. Interesting, and it's set of 5. So 4 of them go down in value. Huh. That's interesting. 4 of them go down in value, and they are all connected. So you could have 1, 2, 4, and 8. And those all go down in value, or those are all going down in value. So that would be 2, 3, 5, and 9. But then you need 1 going up, right? So for all of them going down in value, there's a 1, 2, 4, 8, which all fits that. Everything else does not fit in that situation. So this has to contain 2, 3, 5, and 9 to go down to 1, 2, 4, 8. So this is 2, 3, 5, 9. This has to be 2, 3, 5, 9. And again, this can't be 9. So this has to be 9, which means this is 2. So this can't be 2 anymore, which means this is 2. So the 2, so this has to be 2, which means the 1 in value has to be here. So this is 2, which goes down 1, which is 1 in value. Again, this can't be 2. So this has to be 3, which means it's 2 in value. So you 3 in the corner, celebrate. 5 and 5 it has to be there. So this is 1 in value, which is a 1-2 ratio with 2 in value, which is 1-2 ratio with 4 in value. So this can no longer be 3. So again, this has to be 2 and 3, and this is 5 and 9. Now to bridge this, the lowest this can be is 4. I guess this could be 2. Okay, so if this is 2, it goes down to a 1, so it has to be next to a 2 in value, which since we don't have a 3 anymore, has to, okay, and this also goes up in value because of the 2 by 2. We know that for certain. So because of that, this has to be, so if this is 2 in value, if this is a 2 digit, which goes down in value to 1, this has to be 2 in value, which has to be 1 going up to 2. If this is a 3 in going down to a 2 in value, this has to be a 4, which has to be coming from up, which is not possible because that would have to be 3. So 3 going up to a 4 does not work because we already have a 3 here. So this has to be 1, which is a 2 in value, which is next to the 1 in value, which is a 2, and then that's next to a 2 in value here. And this 2 in value is next to a 4 in value, which would be 5 down to 4, and this would have to be 9 down to 8. So that works. So this cannot be 1 or 5. This can't be 1. This can't be 3. So the 5 can only be here. And for 5 to be in the 1, 2, 4, 8, it has to go down in value. So this is a value of 4. 3 can be either 2 or 4. So this is 4 in value. That could be 3 also. So here we have, now we're looking at what? 4, 6, 7, 8. So the 8 has to be one of those 2, the 4 has to be one of those 3, the 6 has to be one of those 3, and then we have 7. Okay, these all go down in value, so this cannot be 4. This could be 1, 6, it can't be 6 either, 1, 7, 8. This is 1, 4, 6, 7, 8 for all of them. This goes down in value, but 1 going down in value cannot, it would be 0, and that cannot be in a 2-to-1 ratio with anything. 4 could be going down in value to 3, that works. 6 can be going down to value with 5, which also works. 7 could be going down to value with a 6, which would work, and 8 going down to value would be a 7. So yeah, 8 can never, again, 8 can never be next to a black dot. Okay, let's see. This is a 4 in value. The 7 could go up in value. Wait, this can't be a 1. If this is a 1 that goes down in value. Wait, why can't that be 5? I think that's actually wrong. Why can't this be 5? This should be able to be 5. Yeah. Well, anyways, that can't be 5. This can't be 5. 5 is one of those two. I'm pretty sure now this has to be 5. Yeah, I don't know why I eliminated 5 from this because 5 goes down. Maybe I was getting confused by the green being. Green is usually in my mind is going up, but since it's unshaded, it has to go down in value. So that's probably what I was getting confused by. I was thinking 5 was going up, but 5 here in this scenario goes down. And then, but this, okay, so this cannot be 1 because 1 going down in value is 0, which is not a 1-2 ratio. 7 going down in value would have to be 6 in value. But we know you can't have 6 and 3 here because 1 has to go up to 2. So it has to be in a ratio of 2 somewhere. Therefore, the only possibility is this is a 5. So this cannot be 5. So we know one of these is 1, and it has to go up in value, and it's 2, right? So this is 4. Assume this was the 1 going up in value. It can't, because that would be 2. This would be 4. There's no value that can fit both 4 and 2 here. So this cannot be 1. This has to be the 1, and it has to be going up in value. This has to be 2 or 8. This is 2, so this has to be 4. The only way you can get 4 is going up from 3. So this has to be 3 in value, or 4 in value. So this is 4 going up. One of these is up, one of these is down. So this is 4, this is 2. This has to be, it cannot work with any 7. And in addition, we know that's 7 now because of this one. So this has to be 2, this has to be 7. This has to be 1, this is 9, this is 3. So this cannot be 1 here. This is a 1 here. This can't be 1, which means this is a 3-7 combination, which means this can't be 3 or 7. So this 1 is a 2 in value because it goes up. In addition, we know that it has to go down here because it's unshaded, because all 3 of these are shaded. This has to go up in value, so it is shaded, right? So then this would be value of 1, value of 2, value of 4, value of 8, value of 4, and that works. So this cannot be 6, it could be 4, 7, or 8. This can't be 4 or 7, it's 6 or 8. This cannot be 8, it's 4, 6, or 7. Okay. So this has to be 1. This can't be 4 or 8, so this is 1 or 7. This is 4, 7, or 8. We have 3 and 7 here. 7 can only go up to a value of 8. And for the 3 to go with it, it also has to go up. So they both have to be shaded. So we have a value of 8 or a value of 4. And these 3 are shaded, therefore this has to be unshaded. Okay, so this can be 8 here. 6 could be here. We have what else? 3 and 7? No, 3 and 9. So 9 could be one of these two, and then 3 can be all 3 of those. This is 2 and 5. And we have 4, 6, and 7. So 4 could be here, 6 could be here, and 7 could be any of those 3. Okay, and this is 1, 2, and 6. Okay, 6 can only go down to a 5, which would have to be with 10. So this cannot be 6. This has to be 1 and 2. So this is the 6. 1 and 2. The 2 has to go down to a 1, and the 1 has to go up to a 2. The 2 cannot go up to a 3 because that's not a 1 to 2 ratio. So one of these is shaded, one of these is unshaded. Then this becomes 4, 8, and 9. So this has to be 4, 8, and 9, and again, that can't be 8. If this is 4, okay, so what are the possibilities? 9 could go down to an 8, or it could go up to a 10. But if it goes up to a 10, it can't. Can this ever be a value of 5? No, right? Because only values of 4 and 6 can get down to 5. So this cannot go down. Sorry, it cannot go up from a 9. It has to go down from a 9. Hold on, I'm gonna pause because I need to go to the bathroom. So I'll be right back. And I'm back. Okay. Let's continue. This is actually pretty fun. I like this. This is a very interesting spin on the black Kropke dots with the shaded and unshaded regions. Okay. So let's see. Again, if this is a 9, this has to go down to an 8. If it's a 4, it cannot go up to a 5. Right? So again, let's think about that. If it's a 9, it cannot go up to a 10 because there's nothing that can be a 5 on the other side of the black Kropke. If it's a 4, it cannot go up to a 5 because it cannot be 10 on the other side of the black Kropke. Therefore, both of these have to go down. The 4 either has to go down to a 3 in value, and the 9 has to go down to an 8 in value. The shaded cells go up 1. So this is a value of 4, 6, or 8. So 4, 6, and 8 are valid. This would only be 3, 5. 5 is no longer valid. 8 or 10. 8 is valid, 10 is not. So this is a value. So this, again, this has to be unshaded then, because it has to always go down. 4 cannot go up to 5 in value. 9 cannot go up to 10 in value. So they both have to go down. So it has to be a value of 3 or 8. So that corresponds to a value of 6 or 4. So 3 and 5 both go up to 4 and 6. 7 does not go. 7 goes up to a value of 8, which is not in the 1 to 2 ratio. So this has to be green because it's unshaded because it has to go down. This is 4 and 6. So this is a 4, 6 set pair. This has to be 7, 8, and 9. So this can't be 9 because of this number. The 6 has to be one of these two. So this is 6. Because this can't be 6 and this can't be 6, and there's only one other place for the 6. This is a value of 4, 8. So it can only be with a value of 2 or 4. So 1 can go up to 2. 2 cannot go to either one. 5 can go down to value 4. So that's possible. So this could be blue or green. So 5 always has to go down in value. 2 has to go down in value. So 5 goes to 4. 2 goes to 1. 1 goes up to 2. So 2 can never be... 2 is 1 in value. It's always next to the 2 in value. And the only possibility for a 2 in value now is the 1. So this has to be 2, this has to be 1, and that's 5. So that can't be 2, this can't be 5, that can't be 1. So the 2 goes down in value, which means that it is unshaded. The 1 goes up in value, which means it's shaded. So that's 2 to 1. So this is 1 value to 2 value. This has to be 4 value, which means it's going down, which means it's unshaded. So this is 4, which means it has to be next to 8 in value. So this is a 7, this is a 3. So this can't be 3, this can't be 7, this can't be 7. This is either a 3, a 5, or 7 in value. 3, a 5, or 7 in value. It's consecutive with this one, which means it's next to a 2, 4, 6, or 8. But the 8 cannot be here, right? Okay. If this was 7, it could be 6 in value next to it. Okay. So 2 and 4 could be together. Okay, one of these is 2, which means the 2 has to go up. If the 2 goes down, it's 1 in value, but none of these can be 2 in value. So the 2 always has to go up here, which means it's shaded. So the 2 has to be one of these two. And it has to go up in value. So that's therefore a value of 3, which means it has to go with a value of 4, which the only one can be is 5 going down. So this is 5 going down, which means it's unshaded. The 2 has to go up. Whoops, not 1. 2 has to go up, and it's shaded. So this can no longer be 5. There's a 6 or 7. There's a 6 or 7. Okay. This, we don't know what the coloring is. Okay, so this is probably the most interesting part now. If this could be 3, 5, 6, 7, 8 in value. So the values here are 3, 5, 6, 7, 8, which means it could be next to a 2, 4, 5, 6, 7, 8, 9. But the 9 cannot be in value, the 7 cannot be in value. So it could be 2, 4, 5, 6, 8. So if this is 2, this is 3 in value. But this can't be 2 in value. The only ones that can be a 2 in value would be 1 and 3, and that's not possible. So this cannot be 2 in value. Since this can't be 2, well, it could be 3, 4. That's fine. 3 and 4, which would mean 5. So this is 4, 5, 6, and 8, which means this could be 2, 8, 10. 2, 8, 10, 3, and 4 in value. 2, 3, 4, 8, 10. 2 again is not possible. This is, okay, so this is 3, 5, or 7 in value. But 3 doesn't work, 5 doesn't work. 5 doesn't work? No, it could be 5 and 6. So this is 5 or 7. This could be then 6 or 8 in value. So that works. So this is 3, 4, 8, and 10 in value. This could be 2, but it can't be 2 really. So this could be 3 in value, 4 value, 5 in value, 7, 9, and it cannot be 10 because 10 would have to be next to a 9. So 3, 4, 5, 7, 9 in value. Huh. Okay, this is kind of confusing now. So it could be 3. Where is the 2 here? The 2 cannot be here. The 2 cannot be here. The 2 has to be one of these 3s. Cannot be here. So, and that can't be 2. So the 2 has to be here. So the 2 has to be 3 here. So it's either 3 and 4, or this is 3 and 4. So this has to be a 3, 4 value, right? Say it wasn't a 3, 4 in value. We know this has to be 3 in value. This cannot be 3 in value because it can't be next to 4 in value here. So the 2 has to be 3 in value. Because you can never have a 2 in value anywhere here. So the 3 has to be here. So the 2 has to be essentially goes up to a 3 in value, and it has to be next to a 4 in value in this one. So this has to be a 3 to 4 ratio, 3 and 4 value here, which means this is 2 and 5. So this is 2 and 5, which means one of them's blue, one of them's green. One of them goes up, the 2 goes up, and the 5 goes down. So the 5 is green, the 2 is whatever. Okay, so then this is 2, 5, so this is 3, 4. So this is 3 or 4 in value. The 3 could go up to 6, the 4 could go up to 8. So this has to be specifically 6 and 8 in value. If it's 6 and 8 in value, and this is 3 or 4 in value, this is 3 and 4 in value, that means it has to be 5, 7, or 9 in value here, and it can only be 5 or 7. So this is 5 or 7 in value. This is 6 or 8 in value, this is 6 or 8 in value, this is 5 or 7 in value, this is 5 or 7 in value. So this cannot be 7, right? If this was 7, the 7 cannot become a 5 or a 7 in value. Therefore, this has to be 4 or 6. This is 4 or 6. We have a 4, 6 pair in row 7. So there cannot be any 4s or 6s in the rest of row 7. So this has to be an 8. This has to be a 6. This cannot be 8. This can't be 6. This has to be a 7 here. This can't be 7. So we have a 4, 6 pair. This has to be a 7. This has to be a 1 now. So this becomes a 4, 8 pair. This can't be 7. I don't know what I did there. Okay, this can't be 7. This has to be an 8. This can't be 8. So this has to be a 6 or an 8, which means it's a 5, a 7, or 9. Can't be 5 anymore. This is 7 or 9, right? So far these are all kosher. Okay, so we've got all the values. So let's delete those. 8 we don't know anything about. This cannot be 2 or 5. This is a 6. And we have 1 and 4 with it. So 1, 4. One of these is 7, 9. And we have a 3 and an 8 with it. Okay, so what are the values here? What are the values here? This can't be 1. If this is 1, this value goes down to 0 because it's unshaded. So this cannot be 1. This is a value of 3 and 5. So this is a value of 3 and 5, which means this is a value of 6 or 10. 3 cannot go to either of those. 7 could go down to a 6. 8 cannot go to either of those. Again, 8 can't be either of those again. So this is 7 or 9, which means we have a 7, 9 pair in box 8, which means none of the other squares in that can be 7 or 9. So the 9 can go up, and the 7 could go down to a 6. So these are valid. This was 6 and 8 in value. Okay. So here we have 3, 5, 6, and 9. So the 6 has to be here, which means the value is either 5 or 7 here. So we have 5 and 7, so it's 4, 6, and 8. Okay, that could be all of them. So this is 3, 5, or 9. The 3 could go up to a 4. Okay, so this has to be unshaded because of this 2 by 2 square. So this is unshaded. We don't know anything about this. Okay. If this is a 6, it would go down to a 5, and this would have to be 9 to go up to a 10, right? It would have to be a 5-10 ratio. If this is a 4, If it's not a 6, it has to be 4, and that goes to a 7, which that goes down to a 7. So that's a 3 to 6 ratio. 3 to 6 value, which is a 1 to 2 ratio. So 4 and 9 is here. There's a 4 9 here. There cannot be any 4 9s in the rest of column 5. So this cannot be 9, which means this can't be value of 8. Okay, that doesn't really tell us much. Again, so okay, this could be what? No 1, it could be 2, no 3, could be 4, no 5, 6, could be 7 or 8. This cannot be 4 again because of the 4 9 set. This has to be one of these is 1, no 2, could be 3, 4, 8, and 9. This can't be 4 or 9. Okay, so this is 3838. This is 6 or 8 in value. We don't know which. Okay. This is a 6 in value, which means it's either 5 or 7. Hmm. Okay. This has to be blue because we have 3 greens next to it. We don't know anything about these. Okay. These are consecutive. One can never be consecutive. Actually, one could be consecutive. Never mind. One cannot be here, though. If this is 1, the 3 can either be... The 1 would have to be either 0 or 2 in value. The 3 would be 2 or 4 in value, which is not consecutive. The 8 would be 7 or 9 in value, which is not consecutive. Therefore, this cannot be 1. Hmm. If this is 1, that goes up to 2, and it would be next to 4, which could be consecutive. 1 going up to 2 and 4 going down to 3 works. 3 going down or up with 4 going up or down works. 8 going... So if this was 8, this doesn't work. 8 going down to 7 doesn't match anything. And 8 going up to 9 doesn't match anything because it can't be 8. So this is 3, 4, or 9. So the 3 could be with 4. Actually, can this ever be 3? No. If this is 1 going up to 2, 4 has to go down to 3. So this is 1 and 4. If this is 3, this has to be 4, going up and down with it. If this is 8, this is 9. Okay. So, if this is 1, this is with 4. If it's 3, it's with 4. If it's 8, it can't be with 4. But that means this in this pair of cells, there's either a 4 or an 8. We know there's a 4 or 8 here. Therefore, the rest of the row cannot contain a 4 or 8. So this is 1, 3, or 9. So this is 4 or 8. One of these is 4 or 8. These are both... Okay. The 5 again goes down to a 4 value. The 2 goes up to a 3 in value. This could be... Hmm. Okay, we know this is a 6, so it's either 5 or 7. Hmm. This isn't helpful here. This is all connected. We just have to go through the scenarios, I think. There's no more logic involved. We might have... Okay, so for this to be 4, that means it has to go up and the 7 has to go down in value. So if this is 4, this has to be 6. This would have to be 7. This would be 9, and this would be 6. 4 and 7, 9. So this 9 would have to go... Okay, so if that's the case, the 4 goes up. So it's blue. The 7 goes down, so it's green. This 7 is a 6 ratio, so this has to be next to a 2, which goes up, and a 5, which goes down. So the 9 has to go also down. The 6 would have to go up in value. So this seems kosher. The 9 has to go up, and the 6 has this has to be a 6. So far this all seems okay. Oh, actually, well, yeah, we know that anyways. Never mind. So that's if this is 4. That all looks okay. So what if this is 4? If this is 4, this is 7, this is 6, this is 9. The 4 has to go up, which means it's shaded. The 7 has to go down, which means it's unshaded. The 9 must go... Yeah, the 7 and 9 always have to go down, right? If this is 4, it's always with 7. So the 6 always has to be with 9. They're consecutive. But that means the 6 has to always go up, and the 9 has to always... The 4 and the 6 always have to go up, and the 7 and the 9 have to always go down. So we know this is up, these two are down. Right? Yeah. Okay. 4, 6, 4, 6. Don't know anything about this. This could be up or down. Oh, interesting. Okay, so what happens if this goes down? So if this goes down, so this would be 7, this would be 9. This 9 would go down to an 8. This 7 would go down to a 6, therefore this is a 4. This is a 9, this is a 7, this is a 4, this is a 6, this is a 4, this is a 6. This is a value of 8, right? So that means this has to be a value of 4. So this is a 5, which means it goes down. I can't. There we go. This is a 2 that goes up. Wait, hold up. I think I have it reversed again. Oh, no, this is fine. Okay. So that goes up. This has to be a 4, which means this is a 9 and a 3, which is 4 and 8, which works. Okay, so that works. We gotta go through all the scenarios. Okay. So say this went up, and this would be a 9. This would have to be a 6. This would be a 7 going down. So this is a 4 going up. This is a 6. This is 6 and 9. This is 7 and 4. This would have to be a 2 going up. So this would be blue. I can't. This would be blue. This would have to be a 5 going down. So this would be a 1 going up and the 2 going down. So this would be value 3, value 6, value 4. This would be 4 going down, which is 3, and this would have to be 5. Huh. This is getting very complex. Okay. Um, right? We're going through all the scenarios. So then this would be 3. This would be 8. This would be 7. That would be 6. Okay, this seems all kosher. This is 9. This is 8 in value, so this has to be 9. Okay, so this seems okay. This seems okay. So that seems okay too. Okay. Let's go back up in value again. This goes up in value. So this has to be a 9. Wait, no, that goes down in value. Oh, no, no, no. I just meant, okay. No, okay, that's it. Okay. This goes down in value. Now we go down in value. So this is 7, which is 6 in value, so that has to go down in value. That's a 4. This is a 6, so this would be a 6. Interesting. Okay, so we know we tried to make this 5. So what if this were 5? If this were 5 and this were 6, this has to be 3. That becomes 2. This 3 goes up in value to 4, which means the 9 goes down in value. This means this has to... let's just, again, not color this. So say this is 5. This is 3. This has to be 2 then. This is 1. This 3 goes up in value to a 4, which means this goes down in value to an 8. So that's 9. This is 2. This is 5. This is 7. This is a 9. The 2 goes up in value to a 3, but the 9 goes down in value to an 8, which is not a 2-to-1 ratio. So this can never be 5. Okay. There we go. We got some clarity here. This is very complex for this part. Hmm. So if this is, no, this could go both. This could be both. Hmm. If this is 3, this has to go up, and that's 6, which goes down. So say this is 3, it has to go up, so that's a blue, which makes this 6, and has to go down, so that's a green. If this is 3, this is a 5, which is a 6 in value, so that means the 4 has to be here, which makes that 2, this 5, this is 6. So this is a 5 in value, which means this is a 9, which means this is a blue in value. So it goes up. This is 10. This is 7. Oops. This is 7, which is a 6 in value to a 3, which works. To 4. So this can't be blue. This would have to be a 1, which goes up in value. So, oops, it's not green. Blue, this would be 2. This all seems kosher. Hmm. Uh, yeah, this all seems kosher. This would then be an 8, which means this is a 9. This is a 3, 4. This is a 1. This is 7. 4. Yeah, this all seems kosher. I don't know. I don't think we're disproving anything here. Okay. So, if this is 6, this is 4, which means this has to be 7, which is down. This has to be 9, which is down, to a 3 going up. So that's an 8 in value, that's a 4 in value. This has to be a 9. This is a 1. This can no longer be 9, so this has to be 1. Okay, so then this is 2, this is 8, and this is 5. Did that change? I don't know if that changed. No, that did. That was 8 and 8. So then this would be 1. This blue would have to go down in value, so that's on yellow or green. So that's not green. This has to be 2. This has to be a 5 going down, so it's not blue. This is not green. This would be a 4 with a 1. So this has to go up in value, and this has to go down in value because this is a 2, then 3. This would be 7, this would be 2. We'd have 8, so this would have to be blue because of the 2-by-2 ratio. This would have to be blue, so this has to connect this way, which means that's blue, which means that's green. This has to connect out, so then all of these are blue. So this all seems kosher. This has to be, okay, so for yin-yang puzzles, you can never have two on a diagonal and then have the opposite color on the other diagonal. Because if this is blue and blue, how does this connect? It has to connect either this way or this way, but either way, that breaks up these into two separate regions. So this has to be green. This is 6. We don't know which way it goes. So this is 6. I mean, this all seems kosher. This is all just basically trying to figure out what's what. This can no longer be 3, it's 5 or 9. This is 3, so this is 5. Either way, this is 5. I think, right? So we just went around and showed that the 5 has to be here, right? Because then this has to be 3 and that has to be 5. Specifically, the 8 being somewhere. Yeah, the 8 being here, because it cannot be 4 or 9, means this has to be 3, which means that has to be 5. So that's 5, assuming you go the path of that being 6. If it's 3, this can't be 5 anyways. So this can never be 5, which means this is always a 5. This can't be 5. Okay, so the 6 always is in... So one of these is blue and one of these is green. Always. Because the 6 cannot be... The 6 has to be essentially with a 3 or 9, which means that the 3 has to go up to a 4, and the 9 has to go down to an 8. And the 6 would go up and down correspondingly. So this is 5. Man, this is complex. I think we showed this has to be 1 or 8, so it cannot be 3. If this is 3, this can't be 3, obviously. If this is 6, it has to be with 9. Oh, wait, this is 3, this is 5, which means that goes up to a 6, which means that goes down to a 4, which means this is a 6, which goes down to a 5, and that's 9. This is 7, so that goes down to a 6 in value, which means this goes up to a 3, so that's 2. This is 1. So this can't be 1 or 3. Wait, yeah, so this has to be 8. which means this is 8 and 9. So this cannot be 3. Right? So again, if this is 3, that can't be 3, so that's fine. If this is 6, that means this is 4 going down to a value of 3, 7 going down to a value of 6, this is 9 going down to a value of 8, 5 going down to a value... oh, okay. I think we have a contradiction, right? No, that's if this is 6. Right, so if this is 6, then this becomes 4, which means this is 9, so this has to be 3, since that can't be 3. Otherwise, if that's a 3, which means that can't be 3. So 3 cannot be here. 1 has to go up. 8 can go up or down. 9 can go up or down. 4 has to go down. So that's the higher constraint. Maybe that makes more of a constraint. Let's try it. If this is 1 going up, it's 2 going down, 1 going up. This is 4 going down. So 4 goes down, 1 goes up, 2 goes down, 1 goes up. This is 3 or 9. This has to be 8. This becomes a 5, which means the 5 is going down. And this is a 2 with the 2 going up. So this is 5 going down to a value of 4. 9. This has to be 9, which is going down to a value of 8. This has to be 7, which is going down to a value of 6, which means this is 4 going down to a value of 3. 3 and 6. This has to be going up and shaded. This has to be going up and shaded. So this has to be 9 going down to a value of 8, 3 going up to a value of 5. Okay. This has to be 6, which means it's going up in value. And this has to be green and 9 going down in value. Wait, no, that's not necessarily true. This is just 6. We don't know. And it could be with 3 or 9. This is 3 or 9. This has to be 8. We have 7, 2, 8. Okay, one of these is connected, which is fine. 3, 7, 5, 4. Ugh. This is 8. This is 9. This is 7. 7 going down to a 6 in value, which means this is 4. This is 6. This is 4. This is 6. This all seems kosher. Okay. This part I'm not liking as much, I will say. One of these is green, one of these is blue. Yeah, this part I'm not a big fan of, shall we say. Okay, these are opposite each other, which means this is a blue. Which means this has to be green, which means this has to be blue. This must connect, so this has to be blue. This is 3, so this has to be green. This connects again. This is opposite, so this has to be green. This is 3 greens, so this can't be green. This is blue. This is now connected. This all seems kosher. I'm not liking this part because I just have to figure out the shading. This all seems fine. So which way we went? We went that being 6. Okay, what happens if we make it 3? Okay, this can't be 3. So what happens if we make this 3? If this is 3, this becomes 9. This is 6. This is 3. So this becomes 5, which means it goes up to 6 in value, which means this is down to 3 in value. This is 2. This is 6. This is 5. This 6 goes down to 5 in value, which means this goes up to 9 in value. So this is up. This is a 7 in value, which means that this is a 7, which goes down to 6 in value. This is a 2, which goes up to 3 in value, and down 5 down to a 4 in value. So 3 and 4, that's fine. This is a 1. This is a 2. This is a 3. This is a 7. The 1 goes up. So this cannot be green. This cannot be blue. So this is green. The 3 has to go up in value. So this is blue also. This is green. 6 has to go up. So this has to be 8, and this is 9, which makes this 4, this 1, this 4, this 7, this 2. I think the 2 is both there. Actually, yeah, the 2 always has to be there. Okay, so that's another thing we don't have to go along this path to prove. The 2 has to be here in box 8. The 2 has to be here in box 2. We know this forms an X-wing, so there cannot be 2's anywhere else in this column 5 and 6. So this has to be 2. That's fine. I don't know if that helps any. Okay, so again, we tried this as 3 and 6. We're going down this path again. So 3 goes up, so it cannot be green. 6 goes down, so it cannot be blue. This becomes a 5 going up, which is a 6 in value, so this has to be a 4 going down in value. So this is a 6 going down in value, which means this is a 9 going up in value to a 10. So 5, 10. This has to be 7. This has to be 2. The 2 goes up in value, so it's a 3, because it then makes a 3 to 6 ratio. 3 to 6 value, which makes a 1 to 2 ratio. So this is a 5. This cannot be blue. This has to be 1. Then if that's a 1, this is 2. This is an 8. This is a 9. This is a 7, 4, 1. The 1 is going up in value. The blue is going down in value. So that's a green. That's a green. Ah, this is the contradiction. See this? Basically, this blue cell is isolated now. It's not orthogonally connected. Therefore, we know this path is incorrect, is invalid. So, we know this cell cannot be a 3 now. So this has to be a 6. This can't be a 6. We don't know whether this goes up or down. But that 6 makes this a 4, which is a 3 in value, which means this has to go 7 and it has to go down because it has to be 6 in value. This is a 9, and it goes to an 8 in value, which means this has to be a 4 in value, so that's a 5. This is a 3, this is a 9, this is a 7, this is a 5. This becomes a 4, 8, 4, 8 pair. The 2 can, this has to be 8. This has to be 1, which makes that 2. This has to be 4, 8, 4. This is a 7, a 1. So this can't be 1. It's a 3, 9, 3, 9 pair, which means this has to be 8. This is 3, this is 8, this is 4. This is 2, this is 7, this is 9. This is 6, this is 1. So again, the 5 goes down in value, so it's unshaded. The blue 2 has to go up in value, so it's shaded. This 2 has to go down in value, so it's unshaded. This 1 has to go up in value, so it's shaded. Therefore, we have 3 in the 2x2, which is unshaded, so this has to be shaded. Again, we have 3 unshaded in a 2x2, so this has to be shaded. When you have 2 in the diagonal, the third one, and you cannot have the 2 in the opposite diagonal. So this has to be shaded, which means this is unshaded because this is 3 shadeds here. The 4 has to go down, so it's unshaded. The 1 has to go up, so it's shaded. Again, if you have the diagonal, you cannot have the opposite diagonal be the opposite color. So this has to be unshaded. This shaded part must connect with the other other shaded part, so it has to connect, so that's there. This is 3 shaded, so this has to be unshaded. This is 3 unshaded, so this has to be shaded. So the shades are all, this again, this has to be shaded because it must connect that way. This is 3 unshaded, so this has to be shaded. This has to connect to the unshaded part, so this is unshaded. Aha, and that's where it is. So then this has to be connected. One of these is unshaded, and therefore the other one has to be shaded, because if both of them are unshaded, actually, yeah, I don't know. Okay. How is this green shaded connected to the rest? It can only connect this way, so this has to be unshaded. Now, if this is unshaded, this segment of shaded cells is not connected, so this has to be shaded. So this is shaded, this is shaded, this is shaded. Now, if this is shaded, it has to be unshaded here. If this is shaded, this has to be unshaded. But then this is blocked, right? So the only way this connects, and we know one of these is shaded, one of these is unshaded. The only way this connects is if this is unshaded. So this has to be shaded, which means, and to connect again, this has to be unshaded. So this is unshaded, which means the value of it goes down. So this is 6 going down to a value of 5, which means this has to be 3, this has to be 9, this is 3, and that's 9. And we just solve this way. This is 9 going down to a value of 8. This is 6 going up to value 7, 4, 6, and 4. And that's the solution. I didn't like that last part. I understand it. I understand it very well. And I understand that it's very cool the way that it sets up. It's just a lot of trial and error, though. And it's just basically trial and erroring to make sure to see what breaks. Anyways, I love the rest of the puzzle. The rest of the puzzle was very cool. And the last part, I understand. It's to essentially different or not disambiguate the 3-9 pair. It's just that it was kind of painful to try to do that. Anyways, I hope it wasn't as painful for you and that you enjoyed the solve. And I'll see you next time on Frank Puzzles. Take care.